Today, as we huddle around this fire, I will tell you a really scary story, as old as time, of a programmer and the problem he cannot solve. Now, the problem is LeetCode 11, container with most water. Let us for a brief moment leave the warmth of our CSS HTML fire and head over to the cold, desolate lands of my Microsoft whiteboard. Here we have a brief overview of the problem. So we'll be going over the problem, analysis of the problem, and program design. Let's begin. If we are given an integer array, height of length n, there are n vertical lines drawn such the two endpoints of the ith line are I and 0, and I and value at position I. What we are to do are to find two lines that together with the x-axis form a container such that the container contains the most water. What we should then do is return the maximum amount of water a container can store. We are not allowed to slant the container. We have an example. If given the input array consisting of the values 1, 8, 6, 2, 5, 4, 8, 3, and 7, we should output the value of 49. There's an explanation here, but there's no need for us to go over it because it's not even an effective explanation. It's better for us to go over the given image. We notice that the elements of the array are effectively mapped to a 2D coordinate space, that being the x and y axis, where the values of the individual elements of the array are to be considered as lines. We are to find two lines that effectively create the largest rectangle. Well, why do we need the largest rectangle? Because the largest rectangle will give us the largest area, which we will then return. We notice that if we start at index position 1 all the way to the last index position, we get an array of breadth 1, 2, 3, 4, 5, 6, and 7, with a height of 7, giving us 7 times 7. Therefore, we return the value of 49, just as we see here. I had an initial solution that I wanted to implement, but I knew that it would take too long. So I will first show you my second best guess at how I went about trying to solve this mountain of a problem. Again, here's the vector, where I mapped out the values on a 2D coordinate space, where y-axis is the height or value of our element, and the x-axis is the position of the element in our vector. Here is the brief algorithm I was trying to create. What we need to focus on is using two lines to create a rectangle. The shortest line is the length. Why is the shortest line the length? Well, if we took the larger line to be the length, we would then not have created a rectangle. Here's an example of this. If we go back to this example, notice how at position 7 I draw a line right to left, meeting my 8th line. Had I drawn the 8th line to meet the 7th line, it would have nothing to meet right here. And the distance between the two lines is to be considered the breadth. We know that the area of a rectangle is length times breadth. I then have a little more to speak about. When do we switch the dominant area line? My theory was that if we ever come across a line that is greater than height and it's not the last element, I should make the switch. If you're confused, that's fine. Here's a better explanation. Let's say we are in our example run. We read 1, we do nothing. We read 8. 8 is now our dominant line. There is no need for us to backtrack and calculate area. We read in 6. We calculate area as 1 times 6. If we read the value of 2, area is then 2 by 2. If we read 5, the area is 3 by 5. If we read 4, the area is 4 by 4. Once we read 8, the area is 5 by 8. We then read 3, area is 6 by 3, then 18. Once we read 7, the distance between our two values is 7, which will give us the breadth. And the length is also the height, which is the length of the shorter element, that also being 7, which will give us the largest rectangle, thereby the largest area being 49. And this solution did work. It worked for that problem. It also worked for this problem, a vector consisting of two elements, 1 and 1, which effectively returned the value of 1. But this was not good enough. In fact, I believe around test case 16, my program horribly failed. And this is where the true horror began. It was time to go back to the whiteboard. Given this input vector, the answer should be 8, but my program returned 2. This now meant I would have to go back and use the solution that I did not want to use, which is just this, where we loop over a vector starting at position I. We then loop over all elements after I. Let's call it j. We then say area is length times breadth, which is the same as height times breadth, which is the same as the smaller line times j minus I. We only switch area if it has grown. So if we read in a new area that is larger than the previous area, we will make a switch. And we then return the value of area. And doing this, we effectively get the correct solution. And here's the code to implement that. The first thing I want to check is if the height size was 2, which basically means if our vector only had 2 elements. In that case, we find the minimum element and we multiply it by 1. This, in reality, was redundant. Removing this line of code will make your program a little faster. But anyway, we then create and initialize a variable called area. We set it to 0. We then iterate over all values of height starting at 0. And if height at position I is not equal to 0, we will then iterate at all values after position I. We create another variable called minimum height, and we initialize its value using the ternary operator, which basically means if this condition holds true, then we set it to height at position I. But if that condition does not hold true, we say to the value of height at position j. We then check if minimum height times j minus I is greater than our previous area, we make the switch, otherwise we do not. And in the end, we return area. If we run this program, we get the correct answer of 8. If I go back to my whiteboard and I copy this vector, and if I build and run my program, I again get the correct answer of 49. This solution is effective. What is an effective solution? An effective solution is one that solves a problem. In other words, it satisfies the problem. But this is not an efficient solution. In terms of runtime, the larger our height array grows, the slower our program will take to run. It uses quite a bit of resources. Therefore, it is not efficient. I believe I got all the way to the 54th test case out of 62, and that's where things started going really bad. On the 54th test case, I believed I failed a test case with an array of size 10 to the 4th power, which I believe is 10,000, which I also copied and accidentally pasted into my LeetCode editor. So now, if I were to ever go back to this container with most water, my LeetCode just freezes. In fact, I can't do it now because if I do it now, it's just going to freeze. So, for all intensive purposes, I will not be able to solve that problem, even if I want to go back and somehow make my algorithm more efficient. Other things I could do, of course, I could create a new account just to solve one problem. I could copy and paste all my solutions into that new account. I could just email LeetCode. Am I going to do any of that? No. I'm done. I am just done. Now, returning back to the fire, that was my scary programming horror story. Bye.